This ActionQ demonstration shows workflow automation in the context of a database event and an incoming email event. The database event deals with a customer placed on a credit hold. We want to immediately email our CRM team and include the payment history for that customer as an HTML table. Here's the customer table, and we will be demonstrating placing customer 2, Ken Porter, on a credit hold. The email notification to the CRM team should look like this. It includes 2 HTML tables that provide information about the customer and their payment history. These HTML tables get generated by ActionQ automatically. In the description below, I included a link to a previous video demo that reviews several mechanisms for avoiding duplicate notifications. In our case, we'll be using the mirror table approach. ActionQ will also trigger another application, in our case, Visual Cut, and pass some dynamic parameters from the event so it can generate an email allowing the VP of Sales to either reverse or approve the credit hold. Here is what that email looks like: the payment history, which was passed as an argument to Visual Cut. But in addition, we have notes about that customer. The reverse or approve decisions can be done very easily by clicking on a mail to hyperlink. The reverse mail to hyperlink generates this email message. The message includes tokens for the customer ID and the decision, in this case reverse. Here is how the mail to hyperlink properties control the email address, the subject, and the body. The special structure here within square brackets allow ActionQ to parse the incoming message and identify the customer ID and the decision. And that leads to a new event, an incoming email event, that ActionQ reacts to by parsing it and updating the database accordingly. Here's a picture of the overall workflow logic and how the database event is connected to the incoming email event. Here is the ActionQ manager. In the previous video, we already reviewed how these buttons for managing general settings, encrypted passwords, database connections, outgoing email profiles, and incoming email profiles work. So let's focus on the design of our 2 events. The credit hold event is triggered by this SQL statement. Using the integrated editor, if I run it, I can see that none of my customers is currently placed on credit hold. So let's switch to SQL Server Management Studio and place customer number 2 on credit hold. If I now test again, I can see that Ken Porter is indeed on credit hold, and the tokens got populated with information about the customer name, ID, balance, and an HTML table was generated in case I want to insert it into an email message. The event was not triggered because the service is not installed yet. Now let's continue with the subquery. I'm collecting information about the payment history for the customer so that I can email it to the CRM team. And it's a correlated subquery because I'm referring to this token from the main query, the customer ID. So if I run this, I can see the payment history information for the customer, several subquery tokens got populated, and an HQ HTML table subquery now populates with the information in the subquery. So if I click OK and go to the response SQL editor and run it, currently I have only 1 customer on credit hold, but that token, the AF or after how many, will allow me to embed that inside the email message. Let's look at the email that gets sent. It embeds within it a reference to the HQ HTML table subquery and HQ HTML table. So when I preview this, all these dynamic tokens populate and I can see the desired information. The exe response is calling Visual Cut and passing to it several parameters, including the customer ID, the how many, and the full value of the HTML table subquery, in other words, the payment history. So Visual Cut would be able to use that to generate the email that goes to the Vice President of Sales. Let's clear the credit hold on that customer and start the ActionQ service. To see the event triggered, I'll go back to SQL Server Management Studio and turn on the credit hold for that customer. We should be able to see the event triggered within a few seconds, and it did. The credit hold was triggered. It also triggered the subquery. It triggered the SQL after. It ran Visual Cut, passing to it the parameters, and it also emailed the CRM team. Here is the incoming email to the CRM team, including the embedded HTML tables. And here's the email from Visual Cut requesting the VP of Sales to reverse or approve the credit hold. It is now several hours later, and as you can see, we're avoiding duplicate triggering of the same event. Let's switch to SQL Server Management Studio. The customer is still on credit hold, but ActionQ is maintaining an automatic mirror table in another database. Let's look at that table. As long as the mirror table reflects that event, it will not fire again. Coming back to our workflow, let's imagine that we're the VP of Sales and we just received our email. We're going to elect to reverse, and we'll click Send. Going back to ActionQ Manager, the second event, the incoming email event, will fire, and there it is, the event just fired. It triggered a SQL response to update the database. We also sent an email about the fact that the decision was received and processed. So at this point, if we switch to SQL Server Management Studio and refresh the customer table, we can see that now Ken Porter is no longer on credit hold. And here is the email confirming that the credit hold decision was received and processed by ActionQ. While this concludes the second event, there's actually one more final step that occurs back at the database event. The next scanning cycle, 3 seconds later, detects that the database no longer has a customer on credit hold and updates the mirror table so it should no longer have a record. If we switch back to SQL Server Management Studio and refresh the content of the mirror table, we can see that indeed there are no longer customers in the mirror table. Going back to ActionQ Manager, let's review the properties for the credit hold decision event. This incoming email event is conditioned on a particular incoming mailbox receiving an email with the following condition. This is a composite condition that demonstrates that you can filter out emails that don't match your particular workflow logic. There are options to also save the emails as EML files to a particular folder and even save attachments and ensure that those attachments are saved as unique file names. The SQL response demonstrates a pretty powerful feature. The SQL statement is declared as SQL if underscore and then a reference to the decision token. That allows us to specify that depending on the decision, reverse or approve, different SQL statements are going to be triggered. So in the INI file, we have the following entries. The SQL after for this event is controlled by the decision token. If the decision is reverse, this SQL statement is going to be executed. If, on the other hand, the decision is to approve, this SQL statement is going to be executed. Now, this event doesn't call any executable, but it does send an email, and the email message embeds some tokens from the event. I hope this demonstrated how ActionQ can automate responses to database and email events in the context of a composite workflow.